Setting for me to continue on. So I'm going to spend the next 10-15 minutes to talk about how do we build a digital twin? What's the process around integrating with the BIM process during the design construction phase, and how do we take it into operations? So the first step is to create a solid information strategy. And this is most often ignored. We see many projects where the client expectations may be Kobe on everything. That's not a very good situation, because when we get a lot of information, then we can't see the wood from the trees, right? So there's going to be a huge amount of information where we lose sight of what really matters. Knowing what we need is driven by the end outcomes. What are we going to use this for? Is it about maintenance? Is it about optimizing performance? Is it about sustainability? Is it about circularity? And knowing those goals will then drive specific information requirements that we need to specify. Typically, it could be starting with what assets or what building elements do we need to care about. And the building elements may be maintainable equipment, or it could be managed spaces. What are they? What information do we need about them? Who produces that information? At what stage in the project is that information produced? How do we collect it? How do we validate it? And how do we bring it together in an information model? So this is basic discovery of information requirements to drive a digital twin strategy. And if this is done well, then we set the stage for successful outcomes. So typically, this is where we start, and that's what we did with Trinity College as well. And once that's done, we then look at how do we bring this together in the project phase. A project twin has many manifestations. A project twin could be about production of coordinated drawings for construction, and that may be driven out of a Revit model, coordinated with Navisworks or whatever. And that may be just what a project twin needs to do by default to drive the construction process. It may be about driving an estimation system. It may be about driving a scheduling system and being able to visualize progress of work visually. Now, all of those manifestations of a project twin is in the hands of several stakeholders. Who drives the schedule? Who drives the estimations? Probably the contractor. Now, in this project, our scope was about focusing on creating a project twin that delivers an asset twin. So my presentation is more in that context. So the project twin has to establish two pieces of information very critically. What is it in the model? What are the stuff that we care about? The managed spaces and the maintainable assets. What are they? And where are they? Just having these two pieces of information makes it very easy for the rest of the information to be hooked off that. It may sound trivial, but believe me, when you get a BIM model and try to search for something, and good luck, you probably will not find what you're looking to find, because the models are not classified. The elements that are in the model may not know which system they are part of. What are their connections? What are their upstream and downstream impacted elements? So there's a lot of information that needs to be provided just from knowing what is in the model and where is it in the model. And the project twin helps us to make that become real. Now, as we all know, information matures over time. Not all of the information is known when a designer is producing the early designs or even the detailed designs. But we would know what is it and where is it. We would know the performance specifications. But when the contractor makes choices on the equipment is when we know what's the manufacturer and the model and the specific performance criteria about that asset. And during commissioning, there's a whole bunch of information produced. The reason I would like to bring this, present this slide, I wanted to present this slide, was we always talk about LOD as in maturing geometry over time. We are not generally conscious about maturing information over time. And the challenge is in doing that, because it's not just the designers. It's also the main contractor, the subcontractor, the specialist contractor, the commissioning agent. Information is produced by different stakeholders in the process. And not all of them are going to be sitting and working inside of Revit. Because as you know, if you issue a Revit model to somebody, there is no access control or permission, or anybody can change anything. So how do we make sure that the information that's produced by different stakeholders come together in a meaningful way without compromising the integrity of the model? Now, there are two sets of workflows that we've employed on the project. One set of workflows is around model-based data. So the information that can be stored and delivered within a Revit model, for example. There are many technical challenges that we need to be aware of. We are involved in an airport project now where there are 8 million pieces of data specified by the project. When we got involved, 8 million pieces of data was the count. Number of assets that the client cared about, the number of instances of those assets, and I think 160 parameters, many of them duplicates, were all specified. Now, can you imagine what it costs to produce this information? And how is this going to be ever meaningfully used? So and that apart, that model, the project is not complete, it's still in early construction. It takes about 45 minutes for that model to open in a supersized desktop. Supersized. Because every piece of data that we add into a model creates an additional overhead in terms of compute power required to process that model. Now, it's therefore really important to have the model-based workflows defined around the minimum data sets that we need to have from the model, which is what we discussed earlier, which is what is it and where is it. Once we have that, we can then collect information relating to those assets during the normal progression of the construction process from the right stakeholders. It could be delivered through custom web forms. I'm commissioning a piece of equipment, I scan a RFID device or a QR code, a form pops up and I enter the values and that data goes and links back to the model element. I could be collecting type level information. Every piece of pump, every instance of a pump of the same make and model has the same 8 or 10 parameters that the maintenance teams want. Why should that be necessarily put into the model? It can come through a simple data template, captured, transformed, connected back to the model. So there are a set of workflows that can be employed to streamline the process of information management. There are some data that's model-based and some data that's not model-based. And a lot of the information is also in documents. We cannot ignore the fact that there are manuals and troubleshooting guides and inspection reports and quality reports and whatever. There's several warranty documents. There's several documents that get delivered. How do these documents get related back to the elements in the model? Many times you may have observed that the document is stored in a Z drive, in a folder structure, a directory structure with a number of folders, and a URL is inserted into the model. So like a web link, you click on it and it takes you to the document. They very easily break. You update the document or you change the location of the document, that link doesn't work anymore. So there has to be a system by which all of this information actually comes together and is able to maintain itself and progressively get updated and managed. So the asset twin is an outcome of a set of workflows which starts from defining the information strategy. What do we care about? Where is it? What is it? Who delivers the information that we care about? How is it collected? And that process goes through a model-based data deliverable and a non-model-based deliverable. And they all get integrated and to produce the asset twin. So that's the workflow that was used to create the asset twin on the project. So the asset twin then effectively represents the building, the virtual building, the models, the plans, the documents, and all of the data. And that sets the foundation, to Roger's point earlier, to start connecting information about how the building is performing. Because once we have a structured data model that represents everything, we can start connecting that to actual performance metrics that we care about. So the performance twin is really it's not about replacing expert systems. I think this is an important consideration to have. There is a view that a digital twin should be something which does all of the things that operates and manages the buildings. Space management, maintenance management, energy analysis. No. The expert systems represent certain specific functions which they will continue to do. What the digital twin strategy should demand is that these should be networkable. A network of systems that brings together meaningful information and provides a combinatorial value. I don't know if it's a word in English language, but the combination of information when presented meaningfully to the user So they have data to drive decisions. That's really the goal that we are working towards on this project. So some of those screenshots that Roger showed you earlier, the information about the occupancy, the temperature, or the CO2 levels, the system, the operator, somebody in the estates and facilities team, doesn't have to look at every single piece of data. They just have to look at exceptions, and they have to see it in the context of the building. A sensor value with a certain code doesn't really mean much. But if I can see that the air quality in this room is not an acceptable level, and by the way, preventive maintenance on some of these equipment associated with the systems that feed that room has not been done. The service history shows me that I have all of these equipment that have actually broken down multiple times. And I have a cost data that tells me the life cycle cost I have incurred on that piece of asset. Now it tells the maintenance person, or gives the maintenance person an insight to say, I'm getting continuous problems with air quality or with temperature. And I can see that this piece of equipment has been costing me time, and it is money, and it's been breaking down. Should I stop repairing it, and probably I should replace it? Right? So the ability to get these insights come from the combinatorial value of bringing information together from different workflows, different systems, and presenting it in a meaningful way. And this requires some thinking through to make sure that we are not simply presenting everything that's happening onto a screen, but just bringing what matters on a single pane of glass and making it possible for people to make decisions based on data. And when we get to that point, that sets the stage for digital transformation. So as a university with several buildings, the vision would be, how do I benchmark performance of building A versus building B? I can make now decisions about selection of equipment. A lot of insights start coming together when we have structured information and we have a system to look at every building in a similar way, when we can compare apples to apples. Otherwise, when you don't have structured information, we have a lot of data that doesn't give us any meaningful insight. So we are on this journey. We are there right up to the level of an asset twin at this point. The digital twin, the expert systems that come together in the digital twin are already there. Now, the next step would be to bring them together and start presenting them in a meaningful way on a single pane of glass, as I mentioned earlier. With that, thank you.